Here we have our Liberty Engine 1.1. It is an improved version of the Liberty Engine 1.0, a self-sustaining power generator that also includes a 3-phase output. Just as in our previous prototype, we are going to disassemble this 24-volt, 100-amp direct current truck alternator. We remove the protective cover and the carbon brushes. At the opposite end, we remove the shaft pulley and also dismantle the diode rectifier. To do this, we must cut each of the coils soldered to it using a pair of pliers. This component will no longer be of any use. Next, we unscrew the bolts that hold the housing together. By striking it lightly with a mallet, we separate both halves of the housing. We remove the internal winding. And by striking from the opposite side, we extract the shaft. Using this special tool, we will remove the bearing. We will also remove the brush collector. To do this, we must cut the electrical connectors attached to the coil. Now we place the alternator rotor in a precision lathe, and with an angle grinder, we will cut away all of those fang-shaped iron pieces. We must also remove the entire copper winding. It was not possible to remove it using the lathe tool, so we must extract it manually. We smooth the entire surface using this tool on the lathe until it reaches the correct dimensions. This component is manufactured primarily from a special alloy of silver and aluminum. It is a fairly heavy metal due to its density. This piece weighs 941 grams. We fit this component onto the already polished alternator shaft. The two halves fit together perfectly. We secure them with 2 bolts. Now we are going to glue all the N52 neodymium magnets into each of the rotor slots. We glue the magnets with their north polarity facing outward in alternating slots. To bond them, we use cyanoacrylate adhesive. We must glue 2 rows of magnets into each alternating slot. Once all the magnets with their north face have been installed, we will continue by attaching the magnets with their south face. Now we are going to cut this plastic container to create a sealed enclosure. We will also use this plastic sheet taken from a compact disc. We insert it between the blades in this manner, creating a base for the sealed enclosure. We will seal it with hot glue, ensuring that there are no leaks. We position the bottle body that we cut earlier and seal it to the base. Now we are going to prepare an epoxy resin mixture. We add 175 grams of component A and 79 grams of component B. We thoroughly mix the contents and carefully pour the mixture until the magnets are completely covered. "24 hours later, the epoxy has fully cured. We break away the container. We are now going to raise the blade slightly so that we can machine the component. We will machine the surface so that the rotor is perfectly balanced, thus preventing vibrations during operation. We turn the piece to remove the plastic from the sides of the container. With the plastic removed, we must now return the blades to their original position. Next, we must machine the component to a diameter of 104.45 millimeters. In this way, it will fit inside the alternator and remain perfectly balanced to prevent vibrations during operation. We have now achieved the exact dimension we were aiming for. We use a torch to gently heat the surface, which will give it a brighter finish. With this, the rotor is complete. Before assembling the entire unit, we will clean and polish the various components of the alternator. We are now going to assemble all the parts. We place the bearing into one of the end covers. Then we install the stator winding. Next, we insert the modified rotor. Great care must be taken because, as it approaches its position, the magnetic field will pull it abruptly inward. We continue with the upper cover. And fasten the entire assembly together using its bolts. We are going to install this flexible coupling on one end of the shaft. This coupling will allow us to connect the alternator shaft to the motor shaft at a later stage. We have previously threaded the hole at one end of the coupling so that it can be screwed onto the alternator shaft. Furthermore, when this bolt is tightened, the thread will be completely locked in place. Now we are going to machine this aluminum cylinder. This component will serve to mount a manual recoil starter on the opposite end of the alternator shaft. Here we have the manual starter. And this component will be attached to the piece we have just manufactured. We mark the mounting holes. We drill the various openings. And we tap the different holes. Using a torch, we heat the component so that the hole expands and can be press-fitted onto the alternator shaft. We will continue by soldering wires to each of the terminals of the alternator's internal windings. We solder them using tin solder and a soldering iron. And we insulate the connections using heat shrink tubing. We have connected the windings in a star configuration. We secure the wires using cable ties. We screw the starter assembly onto the alternator and verify that it rotates perfectly. Now we are going to manufacture the frame that will support the components of our electrical generator. Here we have all the welded parts. We also drill and tap several mounting holes. Under this wooden base, we will install rubber feet. And now we will position the frame. We have previously prepared the mounting holes required to assemble the frame. Now we are going to install the manual starting system. We have manufactured it from transparent acrylic and aluminum. We unscrew this component once again. We install several washers that will serve as spacers. We position the component centered on the washers and secure it to the alternator using 3 bolts. We screw the central component back into place. And on top of this entire assembly, we mount the manual recoil starter using 6 bolts. Now we are going to install the alternator onto its frame. We use these 4 bolts to secure it. Next, we install the 3-phase motor, which will drive our generator. It fits perfectly, centered within the flexible coupling, and we secure it with 4 bolts. You can view the complete specifications of the motor in the extended version of this video, available exclusively to members. We verify that the recoil starter operates perfectly. We are now going to install a multi-socket outlet strip.
We screw these 2 screws into the wooden base. They will fit perfectly into these slots, securing the socket base in place.
And a 3-phase outlet socket, as many of you requested in previous videos. We will mount it here.
We also tighten the bolt that secures the flexible coupling to the motor shaft.
This will be the power switch. The 3-phase motor is connected to the output side of the switch. In addition, we will connect 3 wires to the input side of the switch, which will later be connected to the 3-phase alternator. We will mount the power switch to the motor using this bracket. We can see that the motor's internal windings are connected in a delta configuration. We will attach the switch and its bracket here. We will route the 3 wires from the 3-phase alternator into this enclosure. We connect these 3 wires to the 3-phase socket. And connect the 3 wires to this terminal block. At the opposite side of the terminal block, we must connect the 3 wires from the alternator and the 3 wires from the motor. We will also connect the 2 wires from the multi-socket outlet strip. Once everything has been connected, we close the housing of the 3-phase outlet. Now it is ready to operate.
Before we continue with the testing, we want to remind you that we've created a private Liberty Engine project community on Skool. It's a community where you can speak freely, where no ideas will be censored, and where everyone interested in free energy is coming together. It's a space for next-generation projects, where we'll even test the prototypes you propose. Plus, you'll be supporting the channel and can learn more about our projects and what's happening around the world in the field of alternative energy. Click the link on the card or the link in the description or pinned post to join. Open minds don't need to be told what to think. They just need to find each other. And we've created that meeting place for all of you. A place where you can speak freely with others who think like you. We look forward to seeing you in the community.
Here we have our completed self-powered generator. We activate both switches and pull the starter cord firmly. The system starts up and continues operating autonomously. We are going to use a voltmeter to measure the output voltage. For the tests, we are going to connect this 3-phase motor. As you can observe, there is no voltage present between the motor terminals. 0 volts. This means that the motor does not contain any hidden battery. Now we connect the plug to the 3-phase outlet of our Liberty engine, and the motor starts running. Now, if we measure between the motor terminals, we can see that we have a voltage of 230 volts between phases. We also obtain the same voltage when measuring at the multi-socket outlet strip. Now we are going to connect this lamp to the outlet as well. Our generator exhibits no variation in power or rotational speed because, thanks to the rotor's secret alloy, eddy currents and magnetic braking are completely eliminated. As we can see, we can continue connecting devices, such as this drill, without any impact on performance. With this 10 kilowatt electrical generator, we could easily supply power to an entire home. When we switch the system off, our machine comes to a stop. Having successfully completed all tests, it deserves the Liberty Engine certification.
Thanks for watching the video to the end. Remember to like and subscribe to the channel for more videos, and consider subscribing to our private community. See you in the next video.